It's amazing something like this can't be specified ahead of time. It has to be generally planned, and then people have to figure it out on the ground. Yeah. And yet, people think you can specify a government for 100 million people ahead of time and plan it ahead of time and then just enforce it on them. And seasteading is a technology for people to figure it out as they go. And this is going to be the first affordable, single-family seastead floating outside territorial waters. And I think once we get the first one on the water, we'll be able to sell a lot more, and people will start experimenting with their own societies.
I think it's I think we even said this with Blue Frontiers too. That's kind of like Roger Bannister running the 4-minute mile too, where it was always possible from a physical standpoint, but the psychological barrier was enormous. You know, because people kept getting closer and closer, and it never quite was doable, or never ever quite pulled it off. But it's like in the same thing too. It seems to be keep getting closer and closer and closer, and it's always like that one little bit away. But it's like once we actually get one out there, even as maybe as simple or quote primitive as might seem, like a few decades later, even though of course it's a tremendous achievement in its own right, we have that psychological barrier broken finally. It's a past tense thing, a present past tense thing, and what's possible from there, once we at least know that it is possible and it's happening right now.
And this is a humiliating moment for me, because there's a great debate among seasteaders between the bullshitters and the builders. And there are many bullshitters that are negotiating with governments, that are talking to engineers, that are talking to architects, and there's a small group of DIY people that are just saying, just go out and build it. Just build it and let the world react. And that's who these guys are, and they're actually doing it. This could be floating outside the territorial waters of any nation in just a few days. So 2018 might have been the last year with no seasteads in it, and 2019 might be the launch of the century of seasteads. We said we'd get one by 2020. We may be coming in a year early.
And it's funny too, you think about, the other analogy that came to mind too is that, you think of the Wright brothers and Kitty Hawk too, and it's like the first plane was built by two bicycle repairmen. Essentially, it's like, what were they doing aerospace engineering? It's like, of all people to try this, they had like a shoestring budget. It is a hobby project. They had no formal training. They were kind of figuring things out as they go. They flew the thing themselves off the hillside. They could have died in the crash. And now what we have down here, we have like, a very good German engineer who's like jerry-rigged half the thing. But what's his background? Is it mechanical or electrical? And he's figured out all the rest himself. Aerospace, yeah. And which, granted, it's a very good system engineering program, but still, it's like he's like doing like electricians work and things like that, like supervising construction at a makeshift shipyard. We've got a software engineer and Bitcoin expert who's like also one of the kind of the engineers, or even like skilled laborers in the project. And our foreman is a local Thai woman who's very enterprising. We've got 2 guys we hired locally to help build the thing and run the backhoe. And it feels kind of like Kitty Hawk all over again to an extent too, where it's like, why is this group of all people the ones doing a complex piece of naval architecture, and yet they're the ones who come closer to anyone else, and it sounds like within 48 hours they'll pull it off.
Yeah. And what I love is it's not the experts with a grand vision, and it's not a big leap to a grand vision. It's people that are just incrementally one step away from getting it done. There's an aerospace guy that was working on a Spar to help him launch rockets, and then he says, oh, the knowledge I already have can be used for this Spar. And then Chad is working in Bitcoin.
Yeah.
Nadia is the famous Bitcoin girl, Thailand.
Yep.
And so people get the concept, and then they get together, and it's just one little baby step from what they do.
Yeah.
They put all those baby steps together, and all of a sudden you have an affordable seastead, which most of us thought was impossible. We thought you couldn't do this affordably in international waters. But it looks like there's lots of calm places on the ocean where there aren't big waves where we can actually do this affordably.
And the cool thing too is that it's like they always say necessity is the mother of invention. I guess we've always, in many ways, we've been kind of looking for a while. Our necessities were often large, ambitious humanity-scale goals too. Whether it's of course lifting the remaining poor out of poverty at some point via the economic opportunities seasteads can present in the open ocean, or saving the oceans, or enhancing political or personal freedom. But my understanding of the whole impetus behind this, and why Rudy kind of went all in it too, is that it was a necessary stepping stone, as he mentioned, for his launch loop, for his aerospace project at sea, and he needed a way to kind of go out there and live for an extended period of time. And so he wasn't inspired by the ideals of seasteading; he simply just needed a way to go out and live on the ocean. And that practical project at that point hooked up them with Chad, and so it's same thing. It became a burning problem that already existed that had to be solved. And I understand that's actually how Elon Musk started SpaceX too. He wants to build a colony on Mars as a life raft for humanity, but wait, we can't even get into space reliably right now based upon the state of the market. We have to go build our own rockets, and thus was born SpaceX. And so, like, what are we looking at here now? It's quote, a baby step, an intermediate step, but it could be turned to be a market or a monstrosity in its own right in the best possible way.
And the thing that's awesome is this is not just a Spar. They're also doing an experiment with what's come to be called coralcrete, a phrase we just made up yesterday, because they're actually going to build, they're going to grow coral on the side of the seastead. They're going to attract fish that won't need to be caged, because you have a coral farm out there in the middle of nowhere. The fish come and stay there on their own, so you could just fish them as you like. You're basically farming fish that are free and uncaged. And so you're increasing the amount of life on the ocean by building seasteads. And it's happening at the first step. And it's just them figuring out, like, well, how are we going to eat? What are we going to do? It's like, well, grow coral, attract certain kinds of fish and plants, and we'll have food.
Yeah, and it's that whole example again where it's, we had the lofty ideals for wanting to try something like this, but again, necessity kind of crept in as a real mother of invention here too, where I think beside the food, I thought part of it too was actually preserving the integrity of the structure over time too, as part of by essentially using the cathode anode plan they have here too. They have sacrificial anodes, but then even the cathodes themselves attract coral, and you get this bonus then of course, you're basically restoring coral reefs on the fly and getting the fish too. And of course, you could look from a local standpoint, oh, we want to restock the oceans with their fish supply and restore coral reefs, but heck, there's one thing to not rust.
Right.
Again, it's the most basic, immediate need possible, actually driving something quite innovative, and that kind of summarizes so many aspects of this project overall.
Right. And Shannon Lim, who runs On Hand Agrarian in Singapore, he was pointing out that makes a seastead an appreciating asset on the sea, unlike a home on your land, because as you grow the biorock around it, it becomes more sturdy, it lasts longer, and it's more resistant to wear and tear, and it becomes encased inside this thing and lasts forever. I think it's brilliant. They're solving so many problems at once. It's almost like what I was writing about in the book and what Patri and I were talking about on a grand scale. It's like the microcosm is actually being done by people that I don't think are even aware of the book, but we're just trying to solve the little problems on their own scale.
I think it's didn't Hayek write about this at one point too? I think he was saying how, it's you look at so much of history, often it's a series of colossal accidents and trying to, scratch various itches at local places over time. And said often we had no idea what we were doing up this point in the century. And of course that resulted in some mistakes and unintended side effects, whether it's pollution or other types of, undesirable externalities. But then out of this too, we also wiped out 90% of the world's poverty. We basically are on the verge of wiping out smallpox. We already have. I can't recall what the current, how many cases are left in the wild at this point, if any, too. And it's just amazing, again, the aspect of it's amazing anything works at all through this series of accidents and local stabs at making things better. And look at here we are now again.
Yeah. And in my opinion, slightly biased, seasteading is the most Hayekian thing you can do. I mean, yeah, we're so networked now, and we're trading information so fast all over the world. We're basically acting like a giant brain. And each of us is acting like a neuron, reacting to local conditions, whether it's prices or job opportunities or requirements or whatever we're passionate about, spontaneously in the moment. And we don't even understand what's going on. But we're solving problems by decentralizing the knowledge and allowing it to spread really rapidly. So yeah, we're solving all these problems really quickly. My favorite book is The Rational Optimist by Matt Ridley. So a lot of these information technologies especially are on exponential trends. What's the thing that's stuck in previous centuries? In my opinion, it's governance. So it's kind of like we're trying to create blockchain smart contracts with 17th century governance technologies, and it's not working, and rules written 50 years ago. So if you actually decentralize all these different little single-family seasteads all over the water, and they could choose and move about, now you have a selection process, now you have a market, now you have everything that Hayek talked about in the technology of governance itself.
Yeah. Archimedes is my favorite historical figures too. And what I love about Archimedes too, we actually were talking about this in the car ride in here too, is that the man was a theoretical genius. I mean, I think he was on the verge of inventing calculus, or had invented it at the time. I think the Romans killed him.
Really?
Essentially. Yeah, it's a story. It's. I don't know to what degree this is verified, but supposedly no. I think the story goes the Romans found him on the beach drawing his circles, and I suppose he was on the verge of like figuring out how to take, figure out the tangent slope, things like this. And I suppose some disagreement. The Romans killed him, and that may have been a story from our calculus teacher growing up to go and keep us interested in the subject. But no, I think he came very, very close to either inventing calculus, or maybe he did, but the knowledge was lost until Newton and Leibniz came along. What I found fascinating about Archimedes was that the man had, we're talking about like feedback loops again to my computer, he had a really tight feedback loop for theory and practice. And, he designed his Archimedes script and he built it and saw how it worked. And so he was getting that tight feedback loop and how his theoretical expectations on fluid dynamics and the like were actually working really. You go back and you can refine things and look at the progress he made there. And then likewise, you look at when thermodynamics really matured in the late 19th century, it wasn't simply because of maybe, let's say, some interest in the subject that I'm sure was where too, is the fact that people actually needed to go and run more and more sophisticated steam and then internal combustion engines. And so practice informed theory and vice versa. And there was simply, if nothing else, there was a desire to go and outstrip your competitors to actually make these things work at the time too. And so I think it's why we saw such huge advancements in, the mathematics of graph theory in like the first decade of the 21st century too. Certainly the interest was always there, but now you had to go out and use to build a better social network. You had to just math to make some of these problems in computation and starts tractable. And that pattern repeats over and over again in history. And so I wonder, what advances this will spur in fluid dynamics. Again, maybe we'll finally solve Navier-Stokes, like one of the hardest problems in mathematics, but it's critical to understanding fluid dynamics well. Maybe we'll get some new advances in material science and bioengineering. So. Of course, it's easy for us, the useless, to author and software engineer in their welding experience, to stand up here on the roof of a rusty boat and pontificate about what the people doing the real work down there actually solving as they try to get the damn thing in the water and get it functioning. But yeah, I mean, it's a tiny little spark that's trying to think where it might go in the next decade, 2 decades, or so on.
Yeah, it's like a little seed being planted in the ocean. It sounds like what you're saying may echo your own experience studying mechanical engineering.
However, briefly. So
yeah, there was not enough practice and too much theory.
Yeah, so we, for some context, we actually had a really interesting discussion on the car ride on the way here. And so Chad and I were both originally looking at being mechanical engineers way back when university, and I think by hook or by crook, kind of ended up in the software field because our experience with that mechanical engineering, it's we spend a lot of time studying the viscosity of oil and the stress and the strain. Of course, it's critical, but it's like, wait a minute. That's nice and all to go refine what you're doing, but where do you actually kind of get your hands to actually go out and build things and experiment and try things? And it's, I know if I have kids someday or a young person, I'd say, look, go to your classes, get your degree there, but make sure also supplementing with your own building experience as soon as possible. Like join the robotics club, join in high school or college or wherever to learn to weld, do things like that, and that'll be your real education. And that's how you'll actually do well in the job, in spite of whatever you do or don't get in your classes. And so we like software because ultimately you get to both design and build and test and get all those pieces of feedback in there at once. And you need to go very, very fast doing this sort of thing too. Whereas to ultimately go the same thing in the mechanical world, in the world of atoms, as Thiel put it, it takes a lot more work to kind of get all those pieces into your hands, into your brain, and often you don't get it automatically in a lot of traditional degree programs. But yeah, it's like we were just saying, it's it would be kind of cool to take, if money and time and obligations were an option, kind of come out here and just learn to weld, learn to build a seastead, all the steps involved there, learn to weld the thing, learn to put the electrics in, to attach the solar panels, I guess is how it floats. And then, I feel like a young person studying engineering, this sort of thing, should do that first almost, learn to go out and build, learn to build your hands, see what actually happens in the real world after the blueprint is made, after the CAD is made, and learn how to kind of go from there to actually out in the ocean to make it work in the real world. And then you can work back from it. Okay, now you know how it works in the real world. Now you can learn the CAD. Now you can learn the drafting to actually go out and design with it, because you actually know like what's the delta between what's on paper, what's on your computer screen, to what's actually happening out here too. And I think Chad and I were saying it's like, I wonder if enough capital comes in, if like Rudy and Chad and this company can build like an apprenticeship program at some point too. And that would actually solve, I think, a lot of the problems we saw here in building this first thing. You've got a committed, interested workforce of smart, willing people who now get the skills gap come in, and it's like now you know who to call, the best trained workforce in the world, to go build one of these things. You know where them not showing up or not being interested is definitely there, and in the meantime they actually have useful skills to go pay the rent on land until this industry takes off. And that maybe it could be the solution to kind of make sure we have a useful well-motivated workforce to make sure that seasteads can get built on time, reliably, no matter where these things are made in the world.
Well, it's amazing how our plans don't work out, even at the level of running a nonprofit like the Seasteading Institute.
Yeah.
Like I'm preparing a report of what we've accomplished and what we're planning to do for the board. And I have to do this every 6 months. And as I'm doing it, I'm like, okay, what has happened every 6 months? Every 6 months, I'm like, we had surprising failures and surprising much better accomplishments, which I did not predict in my previous report. Now I'm writing another report about what our plans are. And every single time, new opportunities are coming in that cause us to have to adjust and drop that idea and go with this idea. And this single-family seastead has just emerged, like in my consciousness, just like in the last month or two. And it seems to me like the most important step we've made as people getting the word out. So yeah, it's improvisation all the way down.
So as is the way of things with this one, they're about to push this thing out right now.
Really?
So
all right.
we were thinking tonight at whatever time, but
So yeah.
Water's deep enough? We can make it happen?
Confirm what I just said. Yeah. We were going to roll this out at 8:30 tonight.
Yeah.
And we're going to roll now. They're going to roll it out now because we had a whole plan having to do with tides and the setting of the moon and the cost and our competence, of which I have none. And now these guys are making it happen now.
when they first rolled it into the water, I was going to have the drone watching the whole thing. It's set up. So we were sitting there waiting, and we were waiting for the truck. It was just driving around. And then I was like, oh, maybe I should go set up the drone. Then I saw the truck moving toward the cylinder. I'm like, they're doing it right now. So I'm like, get the drone. I ran over with my cell phone, and it's like in the water. Like, oh.
Wow.